Okay, so the average value of a function, notice the wording is value of the function, not the same thing as the average rate of change of a function. So the idea of average value is that we will use an integral from a to b to add up all of the y values between a and b. And then we divide by how many y values we have, which is the difference between b and a, so that we end up getting the average function value. Geometrically speaking, that's the same as saying that the function value gives us the height of a rectangle. The difference, or the dx, gives us the base of the rectangle. And the 1 over b minus a is the same thing as finding the base of the rectangle, so then we divide that back out. So the overall area is the integral, which gives us height times base, and then we divide out by exactly the base, and so what we're left with is the average height. That means that what we're left with has the same units as the original function. It does not become a slope, it does not become an area, it's still the original function coming back out. Okay, so the average value is this particular formula here. That's different than the average rate of change function. The average rate of change on an interval is f of b minus f of a over b minus a. If we start out with f prime, that is not going to give us the average rate of change if we make that a slope. For example, if I start out and want the average velocity, velocity has to be position over time. So that means it's position at time 2 minus position at time 1 over the difference of the times. That is not the same thing as the average acceleration. The average acceleration is velocity divided by time. That would be the second velocity minus the first velocity over the difference of the times. So what that means is if I have the f prime function, I have to go backwards from f prime, anti-derive, to get f of b minus f of a. And then I divide that by b minus a. So the average rate of change of a function, if you have the function, is done as the slope of the function. If you have f prime, you have to go backwards to get the function in order to then do the average slope. So notice what would happen here. It does not work to cancel the function. Please do not cancel pieces of the function. But geometrically speaking, we could think of these two things as canceling out, and then I have the average f prime, so the average slope. Okay. So if I start with the position function, then average velocity is position over time. If I start with the velocity function, I have to go backwards from velocity to get position, and then I can divide that by b minus a. So then this would give me what I want for average velocity. If you watch the units, be careful of the units on your problems. That will usually help you to get the right answer. Okay, so for number 1, if I'm looking for the average rate of change of f, the average rate of change of f, ignoring whatever we start with, the goal is to get f of 3 minus f of negative 3 over 3 minus negative 3. That means if I substitute 3 into the original function, because I do have the f function, I can get those just by plotting 3 in. So if I put 3 in, I get 9 minus 6 plus 3. Minus, if I substitute negative 3 in, I get 9 plus 6 plus 3. All over 3 minus negative 3 becomes 3 plus 3. So we end up with 6 minus 18 over 6. So we end up with negative 12 over 6, which is negative 2. So we have basically found the slope of the secant, the average rate of change, which is the slope of the secant, and that really just means 2 points. That's really just algebra 1 slope. For this particular curve on that interval. So we're basically saying that we would have something like this. So if we had the curve, that the average slope between those 2 points would be negative 2. Now, we still have the word average when we do average value, but the value of f is not the same as the rate of change of f. Okay, the value of f and the rate of change of f are not the same thing. So the value of f means we're going to add up all of the f values, multiply them by the base, dx, and divide by the base. So again, not inside the formula. You can't just cancel these out, but geometrically, those things cancel, but only as a concept. You can't just cancel the formula away. So we're going to end up with 1/6, the antiderivative of f, which is 1/3 x cubed minus x squared plus 3x from negative 3 to 3. So that's 1/6. 27 over 3 would be 9 minus 9 plus 9 minus negative 9 minus 9 minus 9. So we get 1/6, 9 minus negative 27. So 1/6 of 36, or 6. So what this is saying is with the exact same function, the average height of the function, how tall the function is 6. That's not the area anymore, it's just how tall the function is on average. Okay. For number 2, we're looking for the average rate of change of f on an interval is always written as f of e minus f of 1 over e minus 1. So that would be the natural log of e squared plus 2e minus 2 minus the natural log of 1 plus 2 minus 2 all over e minus 1. So that's the natural log of e squared plus 2e minus 2 minus the natural log of 1, which is 0, over e minus 1. So the natural log of e squared plus 2e minus 2 all over e minus 1. I wanted to write this one out so that you're aware that you can't simplify this. Okay, the natural log can only be simplified with a power, product, or quotient on the inside. You cannot simplify across a plus and minus. It's like the idea of foiling or composition of angles inside of tangent or sine. You can't just ignore and substitute across. You can't distribute a function. Functions don't distribute to what they're actually composed with. Okay, you would have to do some other properties. What I could do is use my calculator for a question like this one. So we want to talk about how we would put that into our calculator. Okay, so if I were to do this on my calculator, I would store, since I'm going to use this particular function more than one time, I'm going to store the function into y equals. So I would type in the natural log of x squared plus 2x minus 2. I'm And I would quit and go to my home screen, and I'm actually going to put this in exactly as the fraction reads on my paper. I store this function into y1, so I can put the fraction in, and I can do y1 with the number e inside of it. And so the number, you have a function e here above natural log, but we also have the number e, which is really the same thing, but this one requires me to put e to the first power, where this can just be the number e. Okay, so f of e minus f, which is my y1, of 1 over e minus 1. So 1.386. So the average slope of this function starting at 1 and ending at e is 1.386. The average value would be set up as 1 over e minus 1, starting at 1 and ending at e, f of t dt. Now, since I'm not going to antiderive this by hand, and actually I could not antiderive this by hand, I'm going to leave this the way that it is and just use my calculator. So notice it's y value, so the height, dt, the base, divided by the distance of the base, which is the difference between these two. So I'm going to again put the fraction in, 1 over, and this time the e minus 1, my fraction, the integral from 1 to e of the function I've already stored into my calculator. So the y1. 1.517. Okay, for this next one it says find the numbers b, so there's more than one number, such that the average value, but the value of f, not the slope of f, the value of f, on the interval 0 to b is equal to 3. Okay, one thing to notice is that the numbers have to be on the interval 0 to b, so they have to be between 0 and b. So basically we have to have b be a positive number. So the average value on that interval is 1 over b minus 0 from 0 to b, 2 plus 7x minus x cubed dx. So again, we have height times base divided by base. So this is where it becomes really crucial that you have the understanding that the dx is required. That's not an optional part of this equation. So if I were to antiderive, I would have 2x plus 7/2 x squared minus 1/4 x to the 4th from 0 to b. So if I substitute in, I have 1 over b, 2b plus 7/2 b squared minus 1/4 b to the 4th minus 0 in this case. And this all has to equal 3, because our goal was to have the average value equal to 3. So I would probably, before I use my calculator, simplify a little bit to have this just be 2 plus 7/2 b minus 1/4 b cubed equal to 3. Simply because it would make plugging into the calculator a little bit easier. But now I'm just going to find the intersection. So 2 plus 7/2 or 3.5 x minus 1/4 or 2.25 x to the 3rd needs to intersect with 3. So notice this is going to happen more than once. We expected it to happen more than once because it says find numbers, not just a number. Okay, and remember what we said about our interval being from 0 to b. We can't use a negative value. So we're going to have to find these two values here. To do second calc, number 5. Enter, enter. And I want the one that I'm closest to, so it looks like I'm pretty close, so I'm just going to press enter. and 0.287. So B equals 0.287 is one of our answers. We're going to repeat second calc, intersect, enter, enter. We don't want the calculator to find the same answer again, so we want this one. So for my guess, this keeps me from having to arrow over. I'm going to guess that it's 1, 2, 3. It looks like it's between 3 and 4, so I'm going to say 4. I'm guessing that it's close to 4, so it found the value close to 4 that is correct. So 3.5896, 589 rounds up to 590. So it'd be 3.590. So those are the two values starting at 0 that would have an average height between them of 3. The next question says, in a certain city, the temperature in degrees Fahrenheit T hours after 9 a.m. is approximated by the function temperature of time equals 50 plus 4 sine pi time over 12. Find the average temperature during the time period 9 a.m. to 9 p.m. The average temperature. The function that we have is temperature. So we're asking for the average value of what we already have. So if you want to think about what would make sense on there, one of the ways that I check for reasonableness is I ask myself, what would the temperature be at time 50? The temperature at time 50 is going to be, at time 0, sorry, the temperature at time 0 is going to be 50 degrees Fahrenheit. My average temperature over that time period should not be drastically different from what the temperature would be at time 0 or at time 12. I'm using 0 and 12 because it says T hours after 9 a.m. So 9 a.m. is time 0 and 9 p.m. would be time 12. So if I were to substitute 12 in, we end up with sine of pi, which is also 0. So my temperature starts the day at 50 degrees and it ends the day at 50 degrees. So we would expect the temperature to be a little higher during lunchtime, but our temperature should not be drastically different from 50 degrees Fahrenheit on average. So what that means is we are going to do the average value of the temperature. So that means 1 over 12 minus 0, 0 to 12, temperature of time dt. So I have 1/12, 0 to 12, 50 dt, plus 1/12, 0 to 12, 14 sine pi t over 12 dt. So the first part is going to be 1/12, 50t from 0 to 12. The second part is going to be a u substitution. I'm going to factor out the 14 and put that over the 12. So I have 7 over 6. But then I have the sine of u. So my u is going to be pi over 12t. So du is pi over 12 dt. And 12 over pi du equals dt. So that means I technically have 12 over pi du in place of my dt. So if my 12 is the time value, if I substitute that into the u, then I end up with 12 over 12, so that ends up being just pi. If I substitute 0 in as my time into the u, I start at 0. So that means that I have 50 over 12, or 25 over 6, 12 minus 0, plus the 12 over pi I'm going to put with the 7/6, so that I would end up with 14 over pi. And this antiderives as antiderivative sine is negative cosine of u from 0 to pi. So now we have 25 over 6 times 12, which makes 50, which is actually our initial temperature, minus 14 over pi, times cosine of pi minus cosine of 0. So notice that I factored this negative out. Cosine of pi is -1. Cosine of 0 is 1. So we end up with 50 minus 14 over pi times -2. So 50 plus 28 over pi degrees Fahrenheit. And just to show you what the decimal answer would be for that, 50 plus 28 divided by pi would be 58.913. So 58.913 degrees Fahrenheit. Make sure your answer makes sense. Okay, now I did do this question by hand on purpose because I wanted to show you this U substitution here. You will see U substitution problems that require you to end up with a pi on the bottom. That happens more frequently than you would imagine. So I wanted to show you, but had this been a calculator question, I simply would have gone straight from here into my calculator and never have done anything by hand. I wouldn't even have to copy down the temperature equation if I'd had the calculator problem. Okay, now notice what would happen, just for reference, if you had not done average value but done average rate of change. If my initial temperature is 50 and my final temperature is 50, if I had done average rate of change, I would have gotten 50 minus 50 over 12 minus 0. I would have gotten 0 degrees Fahrenheit. That would definitely be a good clue that I didn't do the right thing. 0 degrees is not the average temperature of a city that has a temperature of 50 degrees at noon, 50 degrees at 9 a.m. and 50 degrees at 9 p.m. So make sure you're thinking through the problem answers that you're getting and making sure they make sense. Okay, I want to do another one that requires a U substitution. So it's the average but value of F, not rate of change of F. So we want to do 1 over 4 minus 0, because that's the base. The base is 3. From 1 to 4, add up all the y values, or get the height, times dx. So again, the base and the dx really cancel because both of those are technically the difference in the x. So we have 1/3, the integral from 1 to 4. And this is going to be an e to the u situation. So my u is the square root of x, or x to the 1/2, which makes du equal to 1/2 x to the negative 1/2 dx. That means that du is 1 over 2 root x dx. I have a perfect substitution for exactly du. So I have one other thing to change. My limits. If x is 1, the square root of x is going to also be 1. If x is 4, the square root of 4 is going to be 2. So now I never, ever, ever get back together with my x. So I simply antiderive e, which is still e. So I have 1/3 e squared minus e to the first, and I can leave it like that. Okay. Now, reading this next part. A piece of steel starts out at 1500 degrees Fahrenheit, is removed from the oven and placed in a room at 70 degrees Fahrenheit. So if you've taken physics, you may remember that Newton's law of cooling says that the rate the temperature changes is proportional to the difference between the temperature in the room and the temperature the object initially starts out. So whether you start off with ice cream that's frozen at negative 32 degrees, at 32 degrees, that would be really cold, 32 degrees Fahrenheit, and it was going to warm up to room temperature of 70. Or if you have something that is 1500 degrees coming out of an oven and is going to cool to a room temperature of 70. The bigger the difference between the temperatures, the faster the object will change temperature. Okay, so Now, the temperature of the still is in degrees Fahrenheit is given. So we have the temperature. The time is in minutes, but it asks us for the average temperature. So if you want to make sure you're doing the correct thing, think about what would happen. If I do temperature over time, like average rate of change, like this function, I would have degrees Fahrenheit over minutes. That is not my goal. Also, if you think about what happens if you do that, if the piece of steel is cooling off from 1500 degrees to 70 degrees, it is going to be cooling very quickly. That means that you would get an extremely negative slope as your answer to average rate of change. If you're asking for the average temperature, you shouldn't come out with an average temperature that makes sense. That would be negative hundreds of degrees. Negative hundreds of degrees Fahrenheit would practically disappear. It would almost have to dissolve the steel for it to be that cold. So that's not going to happen. It would have to almost implode. Okay, so find to the nearest degree the average temperature over the first hour. Okay, so the first hour is T equals 0 to T equals 60 minutes. We do have to make sure our units match up. So if I do 1 over 60 minus 0, add up all the temperatures between times 0 and times 60, and then multiply. So here we have, these are technically geometrically going to cancel and leave us with temperatures. If you think about the units, this would be degrees Fahrenheit multiplied times minutes, and then we're dividing by minutes or multiplying by 1 over minutes. So the units are a very good indication of whether you've done the correct thing with your problem. So for this one, I would go straight to my calculator. I'm going to change my y equals function here to 70 plus 1430 e. Now be very careful. A lot of students type these incorrectly into their calculator. They don't notice the decimal point, or they put the decimal point in the wrong place. It's not 0.02. And it's not just 2, it's negative 0.2x. Do your best to make sure you're making it match your paper. I know it might seem redundant to put the 0 there to some people, but the best you can make it match the paper, the less likely you are to make typo mistakes. Okay. So then I can type in the integral 1 over 60 minus 0, so it looks exactly like my paper. The integral from 0 to 60, the y1 function, which gives me the temperatures, dx. So 189.1659345. So notice it says find to the nearest degree the average temperature. So the nearest degree does not mean you get to pick, well, it's already got a little bit of a degree. Do I count that one? Do I not? It's the nearest degree. The nearest whole degree is 189. So it's about 189 degrees Fahrenheit. So like I said, it's going to cool off pretty quickly, but you should never cool to be less temperature than the 70 degrees that you have. So you shouldn't be colder than 70 degrees Fahrenheit ever. Now the average value, so it's the average, but value of the function on this interval. So 1 over 2 minus negative 2, from negative 2 to 2, e to the x dx. So again, what we're asking for is the ex function from negative 2 to 2. We're not asking for the area, we're asking for the average height. So what is the height average out to be? So our base actually has a width of 4, which is why this ends up being 2 minus negative 2 is 4. So I'm going to type into my calculator. And I really don't need to store e, it's not a very complex function. But I'm going to put the fraction in, 1 over. And just to be sure, if I have a calculator question, I really want to eliminate any errors that I could possibly make algebraically or arithmetically. I'm just going to be ridiculous and type 2 minus negative 2. It doesn't hurt anything. It really doesn't take me that much longer to double check that I'm correct. Negative 2 to 2. And e to the x dx. So 1.813. So This next question is one of the most frequently missed types of questions. Oil is leaking from a ruptured tanker at a rate of 500 E negative 0.4 T gallons per hour. So notice what that says again. Oil is leaking at a rate of 500 E to the negative 0.4 T gallons per hour. So it's going to slow down. It's a decay function. So at time 0, we would have 500 gallons per hour. As we go on toward infinity, we'd eventually be leaking no gallons per hour or close to it. Wording. What is the average rate of leakage of oil in the first 6 hours starting at time 0? Okay. Notice again what we're asking for. We're asking for the average rate. The tricky part about this is that most students read that and do the slope of that function. We're not asking for the slope of the function. We also can't leak oil at a negative rate. We can't be putting oil back into the tanker. That's really what that would mean. If oil is leaking out at a negative rate, it really means we're trying to put it back in. But we already have a rate. So what you want to think about on this is if we do the slope of a rate, we're going to end up with gallons per hour divided by hours. We don't want that. That would be acceleration. We don't want gallons per hour squared. We want the average rate. So what we really want is the average value of the rate function. So again, what I said before about watching your units, if you can figure out how to make the units work without just changing them because you don't like them, if you figure out how to make the units work with the calculus, then you'll get the right process. So if I do 1 over 6 minus 0, because we're doing the first 6 hours, 0 to 6, the rate, 500 e to the negative 0.4 t dt. Then if you think about this, I have 1 over hours, gallons per hour, times hours. So I in fact have these cancel geometrically and I end up with gallons per hour, which is what I want. I don't want gallons per hour squared. So I'm going to go into here. This is a little bit more of a complex function, so I am going to type that in. 500 e to the negative 0.4x, and I'll double check. 500 e negative 0.4 and then x. So then I'm going to do the integral of 1/6 from time 0 to 6 the y1 function I just typed in dx. So we're going to end up with the average y. So 189.434. And gallons per hour. So I'm going to leave the extra practice problems for you to try on your own and check your answers online.